Hi, welcome to this introductory tutorial on LTSpice. Before I start the circuits toolbox section of the website, I thought it'd be a good idea to introduce LTSpice to anybody who isn't familiar with it or isn't familiar with Spice at all. It's a pretty simple tool. I'm just going to go over the basics. I'm going to use the inverting amplifier as an example in this. It covers just about everything that you really need to know to get started in Spice. So first off, Google it, Google LTSpice, and the first or second link down will take you to the download page. Once you get it installed and you launch it, you'll see this screen. Just go over here, click on New Schematic. It'll bring up this schematic. If you don't see the grid, I don't know if it shows up in the video. You can show it if you want by View, Show Grid. So the first thing we need to do is to start adding our components. For the inverting amplifier, we'll need a voltage source, a couple resistors, an op amp, and ground. So start off, come up here to component, click on that, and we'll go add a voltage source. So just drag it over to voltage, and there you go. Click OK, drop it on the schematic. The next thing we'll put down is the op amp. So if you come back over here to the left, go to this op amps subfolder, and you'll see all these LT or linear technology parts right here. These are all linear technology op amps. They have all the imperfections built into them. They have all the parameters, the offset voltages, the noise, everything like that. But we're going to use the ideal op amp that's included, and you'll see it says ideal single pole operational amplifier. You must .lib opamp.sub. So this .lib opamp.sub is a Spice directive, and when you're placing components, it's a good idea to watch out for these because if you don't put this in, it'll give you an error. So just remember .lib opamp.sub. It's kind of frustrating because you can't just copy and paste it. So press OK. We're going to come over here and drop that down right there. Before we forget, we're going to come up here where this .op button, that's your Spice directive. We're going to type in .lib opamp.sub. Press OK, and we'll just go ahead and drop this over here. Doesn't really matter where you put it. So the next thing we need is a couple resistors, and those are accessible right here. Resistors, capacitors, inductors, diodes. This is labeled a net, so you can say V out, V in. This is ground, and this is your wire to connect everything. So if you want to rotate it, you can either come up here and rotate it like so by clicking this rotate button. Here's the mirror. Or you can just take Control R. So drop one of those, drop another one up here, and press escape to get that tool off. Oh, we need our ground still. Drop a ground here, drop a ground there. Now we're going to connect everything with this wire tool. Come up here, connect here, connect here, connect here. And so something about LTSpice is the wires don't bend for you automatically, unless there's a setting that I'm not really aware of. I'm not an LTSpice pro by any means. So if you want to create a wire, you click and drag, and kind of bend it yourself. And if you want to delete something, you just hit delete. It'll bring up the scissors. So delete and cut are the same thing. To refocus, you can see it's kind of off the screen now. Just come up here and click this zoom full extents button, and it'll put you back where you want to be. Now on any component that has a settable value, you'll see, so for example, the components are named by their alphabetical indicator and their numeric sequence. So you get your first voltage source is V1, your first resistor is R1, your second resistor is R2, your first IC is U1. But you'll notice on the voltage source and the resistors you have a V, R, and R. So these are the values you need to set. You don't want to come up here and put in 10 meg or whatever. You want to put it right here on this R. So if you right click, it brings up this little dialog, enter new value for R1. So we're going to say, I don't know, 100K. And then on R2, we're going to give it 1 meg. Now in LTSpice, if I put in 1M like this, even though it's capital, it views that as 1 milli. It kind of ignores case. So you actually need to put in 1 meg. And if you right click on the resistor itself, it brings up a little more options. You can set a tolerance, you can set a power rating. You can actually go in, if you have resistor libraries, you can come in here and select a certain resistor from a manufacturer. It gives you the part number, gives you all the tolerances. That way, if you're laying out a semi-complex circuit and you want to make sure that all your components are going to work together and they're going to give you the result you want, you can do a little bit closer verification with that. For this voltage source, if you right click here, you can say, okay, well, I want to set it to 1 volt. That'll set you to 1 volt DC. If you come in here, right click on the icon itself, you can set up a series resistance, or you can go to advanced, where you still can set up the series resistance, parallel capacitance, and it kind of walks you through setting up a lot of other things. So let's say we don't want it to be DC, we want it to be AC. Well, we can set it to 1 volt AC. We can also come over here and set up the pulse, the sine, the exponential, PWL, which is piecewise linear. Say OK. Now you'll notice that it now says AC1 down here. So if we click on this, we could have just typed in AC1. We can type in the code for the piecewise linear, the sine wave, the pulse wave. We can do all that right here. Right clicking on the icon kind of walks you through it though. So we say OK. Now we've got our circuit set up. So if we want to simulate it, we're going to come up here and click Run. Now the first time you click Run, it'll actually take you to the simulation command dialog. So we'll say DC sweep. We want to run our V1, our only voltage source. We'll say from 0 to 100 millivolts. And if you look down here, it'll tell you what's required and what's optional. So source 1 being these angle brackets is required. Start and stop being in the angle brackets is required. But the type of the sweep, the increment, and second and third source and all their options, those are all optional. If you want to have another source swept, you can. So say OK, it'll run. It'll bring up this graph that's got nothing on it. So what you do is you come down here and you click on this voltage source. Let's see, that's V node 02, and it's not terribly helpful. So what we can do is come down here to label net. We can say V out. And I missed. Try that again. There we go. Now if we run it again, and we go probe on that guy, there we go, V of V out. Now it regraphed V node 2, which it changed apparently to this node right here, because it was already in the graph, but node 2 is no longer the same output node. So that's fine. We see the input, we see the output coming down. But if we want to make it a little bit nicer comparison, we can right click over here. We can enter any algebraic expression here we want. We can add traces, we can subtract traces, or we can just negate this trace. And now we can really see that 10x gain right here. If you want to emphasize that even more, go over here and I'll attach the second cursor there. You just right click to get on these menus. Attach the first cursor here, and there you go. Now we can look down here and we can say the difference is about 500 millivolts. So we have a 10x gain. So that's kind of your basic introduction. I'll be covering some more things as time goes on. I don't plan on these being nearly as extensive as my Eagle tutorials. One, I think Eagle is more complex, and two, I think Spice is a little more intuitive. So, but if you have any questions, let me know. I'll certainly take care of them. I'll certainly cover them. And there will be more topics as time goes on and as is necessary. So, thanks. Make sure to visit us at ece101.com. Lots more information there. I'll have all the links for everything that you need. And